Hi, boys and girls, and welcome back to a Splinter of Winter Fraction Wonderland. We'll be looking at algebraic patterns with fractions. Here we have our goal. We want to be able to describe a pattern, create a sequence, and solve a problem. So if we take a look at our action words, we want to describe patterns, create sequences, and solve problems. And all of those things must contain fractions. Now, if you think about what we've done so far in this unit, we have added and subtracted fractions and mixed numbers, and we've renamed mixed numbers so that we can subtract. We've also modeled. Well, now we're going to put all of that information together, and we're going to use it to solve algebraic patterns, which when we think of algebra, we should always think of the unknown. We're looking for something that we don't know. And then when we think about solving problems, we need to think about what we would use in the real world. So let's put everything we've learned together. Now, when we do that, we are using almost all of our math practices. We're going to attend to precision. We're going to definitely look for patterns if we say one of our goals is to create a pattern. We might have to talk and explain to ourselves like what we're doing. We're going to definitely have to think about what makes sense because we're using this in real life. And we just might have to use some models. And if we're going to use a model, then we definitely should choose the right model or the right tools to use for our model. So as you can see, since we've circled all 8 of our math practices, we are really going to have to tune in order to do well on this lesson. So Jack and Asher decided to raise money by running a race. It's nice of them, right? Jack ran 1 5/6 miles. Asher ran 2 7/12 miles. They must run a total of 6 miles. How many miles do they have left? Okay, let's think. We have Jack and we have Asher. So we have what they've done so far. If we add them together, we'll know what they've done so far. But then we also know that they have to have a total of 6 miles. So they've started already, and we know what those numbers are. And then we have what they need to have by the end. Remember, we're setting up our equation. But what we don't know is how many miles they have left before they get right here to the total. But what we do know is if we add what's left, we're going to call that L. If we add what's left, we'll know, and we'll call this the change, we'll know, we'll get to 6 miles if we add what they have left. So what are we going to do? Okay, we have 1 5/6 plus 2 7/12 plus the number of miles they have left, and all of that has to equal 6. How do we figure this out? You're probably thinking what I'm thinking. We need to add these two together, right? And if we want to figure out what this number is, you probably remember this from like maybe 2nd grade. We're going to do the inverse operation. We're going to move these two to the other side. So we'll have what's left equals 6 minus 1 5/6 plus 2 7/12. Now, what does this mean? Let's look at it again. What's left for them to run is equal to their total of 6 miles minus all of the running that they've already done. So now we have an equation set up. Now all we have to do is use what we've learned to solve it. So what have we learned? How do we figure out how to add these two mixed numbers? You're exactly right. You're thinking what I'm thinking. First, we need to find a common denominator. And we know that the common denominator is the least common multiple of these two numbers, which is 12. So that should be pretty easy. we're going to switch these since this is the one that's going to stay the same. And then 1 and 6 times 2 and 5 times 2. So that means our numerator is 10. Okay, what can we do now? We have parentheses. We learned that in chapter 1. So let's add what's in the parentheses first. So we have 3 and 17 twelfths. 17 twelfths is a fraction greater than 1. So let's look at this again. We are going to say that this is actually 4 and 5 twelfths. And let's look at why. So you won't say, oh gosh, Miss Addison, I'm so confused. Here we have 17 twelfths. 12 twelfths equals a whole. So then we have 5 twelfths left over. Does that make sense? 12 twelfths plus 5 twelfths equals our 17 twelfths. Well, this one is the number 1. So our number here, 3, goes up to 4 because we have a whole right here. This is a whole in 5 twelfths. So when we add 2 and 7 twelfths and then 1 and 10 twelfths, we're going to end up with 4 and 5 twelfths. So now we have 6 minus 4 and 5 twelfths. Now, unfortunately, you might be thinking, how am I going to subtract this? You already know. Just subtract the whole numbers. 6, and then we have 4. What is 6 minus 4? You're right, it's 2. But it's not just 2 because we have a fraction. It's going to be 2 and 5 twelfths. So down here, really small, since that's the space I have left, I'm going to subtract and say, oh, I have 2 and 5 twelfths. And can we write 5 twelfths in a simpler form? No, we cannot. So how many miles do they have left? Jack and Asher have 2 and 5 twelfths miles. We're adding an S because it's more than 1 mile left to run. Congratulations. Let's look at another one that's a little different. Maddie feeds her dog the same amount of dog food each day for 4 days. Okay. The chart below shows how much dog food is left after each feeding. How much food does Maddie feed her dog each day? Let me highlight the important information here. Left. This is the amount of food she has left each day, but the question is asking me how much dog food does she feed her dog each day? So on Monday, she has 3 and 5/6 left, but on Tuesday, she has 26 left. It looks like, if I were to just compare the numbers that I recognize, that the numbers are getting smaller. And it's because the dog is eating the food. But how am I going to find out how much food she's feeding her dog? What I'm looking for is the difference between here and here, the difference between here and here, which is like Tuesday and Wednesday, and then the difference between Thursday, Wednesday, and Thursday. But boys and girls, in order for me to see this very clearly, all of the numbers need to look the same. So let's use what we learned in our last lesson about renaming fractions so that we can subtract them. Because if the dog is eating, that means some of the food is missing. So we know that we need to subtract. So I'm going to pause the video and rename all of these fractions as improper fractions. Now, Tuesday and Thursday are already listed, but Monday and Wednesday are not. Okay, So I renamed each of the fractions. Remember our little process here. We are going to multiply the denominator by the whole number, and then we're going to add the numerator. So let's make sure we understand that. I have 6 times 3 here and here, and then we added 5 to the product here. And so we have 23 sixths, and then over here we have 17 sixths. Now what we need to do is look at the numerator. What is the difference between each one of these numerators? If you're thinking what I'm thinking, you're exactly right. I subtracted 3, I subtracted 3, and I subtracted 3. But we're talking about a fraction. So we didn't subtract a whole number 3. What did we do? There's a difference of 3 sixths. And you're right, that is the same as 1/2. So we could say Maddie feeds her dog 1/2. I assume it's cups, or 1/2 cup of dog food each day. If that's the case, if it's a cup, her dog is really small. Let's keep going. Let's do another one together. Maddie feeds her dog the same amount of dog food each day for 4 days. The chart below shows how much dog food is left after each feeding. If she feeds her dog, 3/4 cup of food, how much dog food is left each day? So we know that these numbers are going to represent how much dog food is left. Now it says 3/4 cup. We need to rename this mixed number as an improper fraction that has a denominator of 4. Oh boy, but we can totally do this, right, boys and girls? Okay, so first let's rename 4 and 1/2 as 4 and how many fourths? Right, 4 and 2/4. Now we can change it to an improper fraction by multiplying the denominator by the whole number and then adding the numerator. So we have, and that'll give us the numerator. So that's 4 times 4 is 16, plus 2 is 18. So we have 18/4. Let's write that here, 18/4. Now, all we have to do is say, okay, let's work our way through. I'm going to pause the video and let's see if you can figure out what we should do for Tuesday and Monday and then for Thursday. Okay, take a look. I've done Thursday and I also did Tuesday, but I haven't done Monday yet. Okay, look at the way that I'm thinking because I've got to use my logical and my abstract thinking mind so that I can figure this problem out. I know that there's an amount for Tuesday that if I subtract the 3/4 of the food that the dog ate, or 3/4 cup, then it's going to equal what she has left on Wednesday, which is 18/4. So I know that there's an amount that if I subtract 3/4, it should equal 18/4. Well, I need to use the inverse operation. 18/4 plus 3/4 equals 21/4. So that's why I have 21/4 for Tuesday, because 21/4 minus 3/4, which is what the dog ate, means that I have 18/4 left. And then 18/4 minus 3/4 is, you're right, 15/4, which I did that part over here. Let's see if you can figure out Monday's amount. Pause the video. Okay, take a look at what we've done here. Finally, here's the problem I want you to try. Pause the video quickly. Okay, take a moment and check your answers. Notice that we added 2 of the pencil holders together here, and we got 6/4. We added another 3/4, another 3/4, and you should also notice a pattern.